Hello Year 11, my name's Mrs O'Neill. I work as part of the Athelston Trust Central team. You may have seen me around one of your schools. I'm going to talk through the November 2019 Foundation Tier Paper 1, and I will cover all the other papers too. If you can, give the question a go before I get to talking through it, and then you can see whether your method matched mine and whether you got it correct. If you need a little bit of help, try looking at the question just for a little bit with my voice talking through it, and then pause and see if you can give it a bit of a go to get to the final answer. Good luck! These sentences are on every paper right at the start. They say, answer all questions, write your answers in the spaces provided, and you must write down all the stages in your working. I'm not sure how many students actually read these 3 lines, but they are really important. Something I would thoroughly recommend is answering all questions. Unless you've written something, there's no way you can pick up any marks. And if you look through your question level analysis from your mocks, it's likely there are quite a few questions where you've picked up 0 marks, not because you got it wrong, but because you actually didn't write anything. Can I please thoroughly recommend that you try and attempt as many questions as you possibly can, writing something, even if you have to go back to them after you've finished the paper. Writing your answers in the spaces provided is really important because the paper gets scanned in for the examiner to mark, and therefore if you write outside of that area, they may miss your bit of working. And finally, writing down all the stages in your working means that you may get credit for your workings even if your final answer is incorrect. So if you type something into your calculator, make sure it's written down on the page as well. If you think something in your head and do a little bit of calculation in your head, write it down on the page as well. The examiner needs to see everything you've done. Now let's start the paper. Write down the value of the 7 in the number 1074. The answer is 70. Here, if you had written 7 tens, you would have also got the mark. Number 2, write 4.58 correct 1 decimal place. The answer is 4.6. That's because if I want 1 decimal place, I want 1 number after the decimal point. That's 5. I look 1 place smaller, it's an 8, which means that I have to round that 5 up, because if I think about a number line, when I've got 4.5 here and 4.6 here, 4.58 is somewhere here and therefore closer to 4.6 than 4.5. So 1 decimal place, it's 4.6. Work out 31.7 times 100. If I multiply a number by 100, I make it 100 times bigger. That means every digit needs to move 2 places bigger. So if I put the 3 that's currently in the tens column, that moves up 2 places. The 1 currently in the ones column is going to move up 2 places. The 7 currently in the tenths column needs to move up 2 places. And to make that happen, I then need to put a 0 on the end, because the 7 has got to go from the tenths column to the ones column to the tens column. And that moves every other digit 2 places bigger as well. So 31.7 becomes 3,170. If I want to write 28 over 70 in its simplest form, that means that I need to find a common factor of 28 and 70. Now, a common factor would be 2, for example, so I could halve both of them and get 14 over 35. But what I'm actually looking for is the highest common factor. It's only worth 1 mark, but in its simplest form, we need to make sure that we found the highest common factor and divided them both by that. So 28 over 70, the highest common factor of 28 and 70 is 14. So if I divide both of them by 14, then I end up with 2 over 5. The answer is 2/5. Now, you could have done that in several steps. So instead of going straight to dividing by 14, you may have divided by 2 first, and then you could have divided by 7, or you could have divided by 7 and then divided by 2. That will give you the same answer, 2/5. Number 5, write 15% as a decimal. 15% means 15 out of 100. So I'm going to first of all write that as 15 out of, I can write that as a fraction, 100. So as a fraction, 15% is 15 over 100. Now this line can also mean divide, so 15 divided by 100. 15 divided by 100, all the numbers need to move 2 places smaller, so to the right, so 15 becomes 0.15. So 15% as a decimal is 0.15. Question 6. The pictogram shows information about the number of pictures sold in an art shop in each of January, February and March. So we've got the pictogram there. We've then got the key, and this shows us that 1 square represents 8 pictures. I'm just going to put a circle around that, 8 pictures. It says write down, part A, write down the number of pictures sold in January. So I want January. January is up here. Each is worth 8. So that's 8, that's 8, and that's 8. 3 lots of 8. 8, 16, 24. 3 times 8 is 24. It then goes on. 12 pictures were sold in April. Show this information on the pictogram. So at the moment there's nothing in there for April. So if I want to show the information on the pictogram, I need to make sure I'm representing 12 using this key. So I know that 1 square would represent 8. Another whole square would represent 16. So I don't want a whole square, but if I've got 8 there, I need another 4, which I think will be half a square. That's for 1 mark there. Finally, what was the total number of pictures sold in these 4 months? Well, I know that each square is worth 8 pictures. So if I count the number of squares, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I've got half a square there and there, so that's 10, plus another half there, that's 10 and a half. 10 and a half squares. So if I do 10 and a half times 8, 10 times 8 is 80. A half of 8 is 4, so I'm going to end up with 84. Remember I said to write everything that you had done, so I've done 10 times 8 is 80, and I know that half times 8 is 4, so when I add those together I get 84. 2 marks. Question 7. Work out the difference in minutes between 1 hour 25 minutes and 1 1/4 hours. Here we've got this first one, 1 hour and 25 minutes, given as hours and minutes, and the second one given as just hours, 1 1/4 hours. I need to convert them so that they've got the same units. I'm going to convert this second one. I know that there are 60 minutes in an hour and a quarter of 60. I find that by doing 60 divided by 4, which is 15 minutes. So here I have 1 hour and 15 minutes. Now I've shown the examiner that. And then I can make a comparison. I've got 1 hour 25 minutes, 1 hour 15 minutes. The difference between 25 minutes and 15 minutes is 10 minutes. Question 8. Prussia has 5 blocks of wood. The total weight of all 5 blocks of wood is 3 kilograms. 4 of the blocks of wood each have a weight of 650 grams. Work out the weight in grams of the other block of wood. Right, I'm just going to read through that again and underline some key pieces of information. Prussia has 5 blocks of wood. The total weight of all 5 blocks of wood is 3 kilograms. 4 of the blocks of wood each have a weight of 650 grams. Work out the weight in grams of the other block of wood. Now the first thing that I spot is that I've got grams and kilograms here. I've got different units, so I'm going to convert this 3 kilograms into grams. I know that there are 1,000 grams in a kilogram, so 3 kilograms must be 3,000 grams. I'm then going to think about the fact that I've got 5 blocks of wood that I need that weigh 3,000 grams, but I know that each of the 4 that have been told about weigh 650 grams. So I need to work out the total weight of those 4. 4 times 650, and that will allow me then to work out those 4, and if I take that away from the 3,000 grams, I'll be left with the weight of the other block of wood. So 4 times 650, there's a few ways we can do this. We could double it and double it again. That's the easiest way to multiply by 4. Or we could do a grid to show our multiplication. So if I multiply by 4, I could do 650 partitioned to be 650 like that. So 4 lots of 600. Well, I know 4 times 6 is 24. So therefore 4 times 600 must be 100 times bigger, 2,400. 4 times 50 is 200. You could count up 50, 100, 150, 200 if you needed to. And then if I add the 2 lots together, so 2,400 plus the 200 leaves me with 2,600 grams. I then need to work out that weight of that final block of wood. So I need to do 3,000, take away 2,600, and we are left with 400 grams. So the answer for my answer line is 400. The units are already there, but do just check, because if it's not there, make sure you put the units on there. 400 grams. Question 9. PQR is a straight line. Work out the size of angle X. Well, we know that angles on a straight line sum to 180 degrees. We know one of the angles is 100 degrees and another one is 35. So if we add those together, we've got 135 degrees. Remaining then is 180. Take away 135 degrees, leaves us with 45 degrees for angle X. So our answer is 45 degrees. Question 10. We've got a graph here and we're told to plot the point with coordinates 3, 2 to label this point A. So 3, 2, I need to go along the x-axis to 3 and then up the y-axis to 2. I'm going to put a cross there and label it point A. Part B then says write down the coordinates of the midpoint of BC. By BC, they mean this line segment here, B at one end, C at the other. So this is the line segment BC. The midpoint then is here. If I put a cross on the line, I need the coordinate of that. So I've gone on the x-axis to -1, so that's the number I'm going to put in first. And the y-axis, I haven't gone up or down, so it's 0. Question 11. Mason throws a coin 3 times. The outcome of each throw is either heads or tails. List all the possible outcomes of the 3 throws. So when we do this, we need to make sure we're systematic so that we don't miss any out. I would start with 3 tails. 1, 2, 3. First throw a tail, second throw a tail, third throw a tail. Then let's reduce that down so that we have 2 tails and 1 head. So we could have tail, tail, head. Or we could have had tail, head, tail. Or we could have had head, tail, tail. You can see how the head has worked on the diagonal there. Then let's flip it and say, okay, instead of 3 tails, we're going to have 3 heads. Head, head, head. And then let's take away one of those heads to have just 1 tail. So head, head, tail. Head, tail, head. Or lastly, tail, head, head. And you can see the diagonal with the tail working back that way. And we haven't missed any out then. 2 marks. Question 12. Rehan is on holiday in the USA. He has $200 to spend on clothes. Rehan buys 1 pair of trainers costing $60, 3 t-shirts costing $25 each. But he also wants to buy a jacket costing $80. So let's think about these key numbers. So we've got 200 there, one pair of trainers costing $60, 3 t-shirts costing $25 each. So 3 lots of 25 I know is $75. He also wants to buy a jacket costing $80. Now the question says, has Rehan got enough money to buy the jacket? You must show how you get your answer. Okay, so we need to know whether you can buy a pair of trainers, 3 t-shirts and a jacket for less, well, £200 or less. So we know that the t-shirts then cost $75 in total. We know the trainers cost $60. So if we first of all do 75 add the 60, we get $135. Has he got enough money left for this $80 jacket? Well, let's check it. $200, take the 135, I think leaves us with $65. So we need to answer this question. Has Rehan got enough money to buy the jacket? No. There is only $65 left after purchasing the trainers and t-shirts. Something along those lines, a little bit of an explanation. The second part then says the trainers cost $60, yeah, we know that. The exchange rate is $1 to 74.9p, or in pounds we've got 0.749 pounds. Rehan says the trainers cost less than 40 quid, less than 40 pounds. Rehan is wrong. Using a suitable approximation, show working to explain why. So he thinks the trainers cost less than £40 when we use that exchange rate. Well, we haven't got a calculator, so we're not going to use 0.749 pounds. Let's round that. Let's make our lives easy. So something we can round that to. If we round that to 1 decimal place, we get 0.7. So let's use that as an approximation. 0.7 pounds for every dollar that we spend. So 0.7 times 60. Now this is going to be an underestimate, isn't it? So we're only using 0.7 rather than 0.749. So 0.7 times 60. And if I did 7 times 6, that's 42. And I've got, this is 10 times smaller, but this one, 60, is 10 times bigger. So actually, I think that is 42. It's the same value. £42 that would cost. Now, using a suitable approximation, show working to explain why. Well, we've explained why. It's an underestimate. There, £42. Therefore, we can't have it costing less than £40 because the exchange rate is actually 0.749. So they would actually cost more than £42. So we've used a suitable approximation. That's the 0.7. And we've shown the workings to explain that it actually costs £42 is an underestimate. So it can't be less than £40. So question 13a says simplify 2a times 5b. So I could rewrite this as 2 times 5 times a times b. We don't use the time signs if we can help it when we're doing algebra because it looks like an x. So 2 times 5 is 10. And then the a times b I'm going to write as ab. So my answer there would be 10ab for 1 mark. Part B then, when I simplify 3x, add 2y, add 5x, take y, which I could put a 1 in there. Let's take 1y. We just don't need to write the 1 normally. That might help us when we're working this out. So simplify. I'm going to collect the like terms together. So I've got 3x and I've got 5x's, and I'm going to keep the sign in front of it with it so that I know that I am making sure I'm adding and subtracting correctly. So I've got 3x's, add 5x's, and then I'm going to have the y's together. So I've got positive 2y, and I've got a subtract 1y there. So when I put them back together, 3x add 5x gives me 8x, and 2y, positive 2y, take away 1y, leaves me with just 1y. So 8x plus y. If you leave the 1 in, you won't lose a mark. You really don't need it though. Question 14, work out 23 times 15. There's quite a few different ways you could do this. I'm going to partition this, split it up as a grid, make it a multiplication. So we're going to have 23, I'm going to partition and make 20 and 3. 15, I'm going to partition to 10 and 5. If I then multiply each of the numbers next to the squares to get my product, I get 10 times 20 is 200. 10 times 3 is 30. 5 times 20 is 100. And 5 times 3 is 15. I then need to add them up. I tend to add up the columns and then add them up separately. So we get 200 add 100 is 300. 30 add 15 is 45. And I know that 300 add 45 gives me 345. That's for 2 marks. 23 times 15 is 345, and I've shown all my workings. You might do a different way. As long as you get the answer 345 and your method and workings are shown, then you'll get the 2 marks too. Question 15. 120 people were at a hockey match. Each person was asked if they wanted to stand or to sit to watch the match. 75 of the people were female. 29 of the males wanted to stand. 30 of the people wanted to sit. Use this information to complete the frequency tree. Right, so let's unpick the numbers we've got here. So we know there's 120 in total. That tallies with the 120 at the start of the frequency tree. So 120 here, and hence we've got 120 here. We know that 75 of the people were female. And so if I come down to the female box, we've got 75 going in there. And then if we go to the male box, then we know that if there were 120 in total and 75 females, if we do 120 take away 75, we end up with 45. So that must be 45 males. The next part then says that 29 of the males wanted to stand. So if we go down the male line and then we get to 45 and then we go down the stand line, it says that there were 29 males that wanted to stand. So we can put 29 in there. And therefore, in order to work out the box for the number of males that wanted to sit, I need to do 45 take away 29, which I think leaves me with 16. So 16 males wanted to sit. It says 30 of the people wanted to sit in total. So 30 of the people wanted to sit in total. I know that there are 16 males here that wanted to sit. So if I do 30 take away 16, that leaves me with 14. 14 of the females then must also have wanted to sit. Finally, I need to work out the number of the number of females that wanted to stand. I know there were 75 females, and if I take away the 14 that wanted to sit, I am left with 61 that wanted to stand. We should notice that 120 in this first box, the males and the females adds up to 120, and finally all this last column, the sit and stand for males and the sit and stand for females, also adds up to 120, so you can do a check. That's worth 3 marks. Part B then says one of the 120 people is chosen at random. Write down the probability that this person is a male who wanted to stand. So if we look at the workings we've done already, the male who wants to stand box has 29 in it. So there are 29 males that wanted to stand. So that's going to be our numerator. And that was out of the total of 120 people. The probability that the person is a male who wants to stand is 29 out of 120. Question 16. Steve drove from his home to his friend's house. He stayed at his friend's house and then drove home. Here is Steve's travel graph. For how many minutes did Steve stay at his friend's house? So let's just interpret this graph. Here on the y-axis, we've got distance from home. That's important, the distance from home. And then we've got this one, which is time of day. We can see here he left his home at 12 o'clock. He then travelled to his friend's house and arrived here where he stops travelling. So that time is here, which if we interpret the scale is 12:45. He then stays at his friend's house until this point on the graph, which is at 1:30, and then he travels home and arrives home at 2 o'clock here. Now, this says, for how many minutes did Steve stay at his friend's house? So we need to find the difference between 12:45 and 1:30. I think there are 45 minutes between 12:45 and 1:30, so we're after the answer 45 minutes here. We could also think of each of these parts being 15 minutes, so 15 minutes there, and then another 15 minutes if we think about the scale, and then another 15 minutes to there. So he stayed at his friend's house for 45 minutes in total. Part B says, what was Steve's average speed on his journey home? Now we know that average speed can be calculated by doing distance divided by time. We look down here, we've got kilometres per hour as our answer units. So we need our distance to be in kilometres and our time to be in hours. So his average speed then is going to be the distance he travelled. So he was at his friend's house 25 kilometres from home. So we can put the 25 in there. So he was 25 kilometres from home. And if I then divide that by the time it took him to get home. So if we look here from 1:30 to 2 o'clock. Now that is 30 minutes. So it took him 30 minutes to get home. However, I need to be careful because it says here that it's got to be in hours. I know that 30 minutes is half an hour. So I need to do 25 divided by a half. So speed is equal to 25 divided by a half. So dividing by a half is the same as timesing by 2 because we're looking to see how many halves fit into 25. So the speed is going to be 50 kilometres per hour. So the answer I'm going to put here is 50 kilometres per hour. Question 17. X take away 1 is equal to 2. Work out the value of 2x squared. So we know that x take away 1 is equal to 2. This question is worth 3 marks, so we want to show all our workings. I know then if I add 1 to both sides, I end up with x on this side and 3 on this side. We can check it. 3 take away 1 is equal to 2. So the value of x is 3. That's going to get me a mark. I now know that I have to work out the value of 2x squared when x is equal to 3. So here I need to be careful and make sure I do things in the correct order. So here this means 2 times the value of x squared, where x is 3. So we're going to do 2 times the value of 3 squared. First of all, I need to make sure I can square the 3. So 3 squared is 3 times 3, which is 9. And the value of 2 times 9 is 18. So my answer will be 18. Question 18. The pie charts show information about the favourite animal of each student at school A and of each student at school B. There are 480 students at school A and there are 760 students at school B. Henry says the same number of students at each school have tigers as their favourite animal. Is Henry correct? You must show how you get your answer. Now the first thing I spot is that this is worth 4 marks. So I need to make sure I'm very thorough with showing my workings. And then if we have a look at underlining some key information. So I know there are 480 students at school A and there are 760 students at school B. He thinks, Henry says, the same number of students at each school have tigers as their favourite animal. So the thing I'm interested in are the tigers. So let's take a look at school A first of all. I need to work out how many students liked tigers at school A. I know that monkeys was 60 degrees and the same number of students liked tigers as liked lions. They both have x degrees for their angle represented on the pie chart. I know that the full circle adds up to 360 degrees. So if I take away the 60 degrees for the monkeys, I'm left with 300 degrees. So 300 degrees is equal to 2x. The tigers add the monkeys' angle, so x add x is 2x. And therefore, if I divide both sides by 2, I get 150 equals x. So 150 degrees is equal to x. I can pop that in there. I therefore know that 150 degrees out of the 360 degrees is for the tigers. So I'm going to try and simplify that fraction to help me. So that's 15 out of 36 if I divide top and bottom by 10. And then if I divide top and bottom by 3, I get 5 out of 12. So in its simplest form, 150 out of 360 is 5/12. So 5/12 of the circle is for tigers. And I know the whole circle is representing 480 students, it tells me here. So 5/12 of 480 is what I need to work out. 5/12 of 480. So the way I'm going to do this is by finding 1/12 first of all. So I'm going to do 480 divided by 12, and then I'm going to times that by 5. So 480 divided by 12. Well, if this was 48 divided by 12, that would be 4. So 480 divided by 12 must be 40. And then I need to times that by 5, and 40 times 5 is 200. So I think there are 200 students at school A that liked tigers. School B then, I think, is a little bit more straightforward. School B has got this angle of 90 degrees for the tigers, 90 out of 360, which is the same as a quarter. And we can see that a quarter of the circle there is representing the tigers. So we need to find a quarter of the 760 students. So a quarter of 760 is the same as doing 760 divided by 4. There's a few ways you could do this, halve it and halve it again. Some of you might like to do a bus stop method, so 760 divided by 4. How many 4s go into 7? There's 1 with 3 left over. How many 4s go into 36? That's 9. How many 4s go into 0? None. So that's 190. 190 students at school B liked tigers. Therefore, if we look at this and go back to the original question, is Henry correct? You must show how you get your answer. No, Henry is not correct. School A has 10 more. And that will get you your 4 marks. Question 19, here is a number line. Write down the inequality shown on the number line. So I've got 2 ends to this number line. I've got a filled in circle at -3. So I'm going to write that down first. And I've got a blank circle, an empty circle at 1. So I'm going to write that number down as well. In the middle, I need to pick a letter. It doesn't matter what letter you pick. And the mark scheme, they pick P, but actually you could use any letter of the alphabet to go into there. I then need to make sure that P is representing that it's bigger, is represented that it's bigger than -3. So I'm going to have my arrow facing that way. And then I'm going to make sure that P is less than 1. So I'm going to have my arrow going that way. And then I just need to check whether I need to make any of these equal to it as well. So because this one here is filled in and a blanked in circle, it means that it's equal to it as well. So I'm going to put a line underneath to show that it can be, that p has to be greater than or equal to -3. And then at this end, because the circle is blank, it can't be equal to it as well. So we leave the inequality sign like that. That's 2 marks. Question 20 asks to find the lowest common multiple of 108 and 120. So we're looking for the lowest number that is in both the 108 and 120 times table. So you could write out your 108 and 120 times table and then find the lowest number in both. But a quicker way might be to think of these as writing them as their product of their prime factors. So if I start with 108 and I'm going to draw a prime factor tree, so I know that 108 is even, so I know that it must be divisible by 2. So I can put 2 there, and 2 times 54 is 108. I'm then going to circle the 2 because it's prime. I'm then going to go off the 54. It's still even, so I know that it has a factor of 2. And 2 times 27 is 54. So I'm going to circle the 2 because it's prime. I'm not going to come off of there. 27 then I know is 3 times 9. And I've circled the 3 because it's prime. 9 isn't prime. It has factors of 3 and 3. So I have now completed the prime factor tree for 108. I'm then going to look at 120. We can do the same. It's even, so I can start with 2. 2 times 60 makes 120. Then it's even again, so I can go with 2. So 2 times 30 makes 60. It's even again, so 2 times 15 makes 30. And at this point, it's no longer even, so I'm going to see if it's in the 3 times table. It is. 3 times 5 makes 15. So I'm going to circle both of those because both of those are prime. So I've now got my prime factor trees. I now know that 108 is 2 times 2 times 3 times 3 times 3. And I know that 120 is 2 times 2 times 2 times 3 times 5. I'm now going to put these into a Venn diagram to help me find the lowest common multiple. So if I draw 2 circles, I'm going to use this one for 108 and this one for 120. So any numbers that they've got in common I can put in the middle. So I'm going to cross them off as I go. So there's a 2 there and a 2 there. So I'm going to put that in the middle. There's a 2 for the 108 and a 2 for the 120. So I'm going to put that in the middle. There is not another 2 so on the 108. So I can put that final 2 from the 120 in there. And then, and I can cross that one off, I've used it. So then we've got a 3 in the 108 and a 3 in the 120. So I can put that in the middle, they're paired off. And then I've got no more 3's in the 120. So I can put those 3's that are left over in the 108, cross those off, I've used them. And then I've got 1 5 left on the 120. I can cross that off and put that in with the 120 circle. Now, to find the lowest common multiple, I multiply all the numbers together that's in my Venn diagram. So let's group them up first. So in the 108 part only, I've got 3 and a 3. So 3 times 3 is 9. So let's write it out longhand first. We've got 3 times 3. In the centre, we've got a 2, and a 3. And I'm multiplying these together. And then at the end, I've got a 2 and a 5 in the 120 circle. So I know that 3 times 3 is 9. 2 times 2 times 3 is 12, and 2 times 5 is 10. So I'm just putting these into smaller manageable chunks to multiply together. And then I know that 9 times 12, for example, is 108. And so it's 108 times 10, which I know then is 1080. So my answer for this would be 1080. That's the lowest common multiple of 108 and 120. Question 21. There are 60 people in a choir. Half of the people in the choir are women. The number of women in the choir is 3 times the number of men in the choir. The rest of the people in the choir are children. The number of children in the choir to the number of men in the choir is equal to n to 1. Work out the value of n. You must show how you get your answer. Now, this bit at the bottom is important. You must show how you get your answer. If you just write a guess in here, n equals whatever number you guess, you won't get the credit and won't get any marks. So let's unpick this. There are 60 people in the choir, and we know that half of the people are women. So I'm going to start there. 60 divided by 2, that's half of 60, is 30. So 30 women. The number of women in the choir is 3 times the number of men in the choir. So the number of women is 3 times the number of men. So the number of men, if I times it by 3, I get the number of women, which I know is 30 because I've just worked that out. So the number of men, I think, is 10. 10 times 3 is 30. So there are 10 men, 30 women. It says the rest of the people in the choir are children. So there were 60 people. If I take away the 30 women and I take away the 10 men, I think I'm left with 20 children. Now, it then says the number of children in the choir to the number of men in the choir is equal to n to 1. So I know the number of children. That was 20. And the number of men was 10. And if I simplify that, I get 2 to 1 by dividing both sides by 10. And it asks for it in this format, therefore the value of n must be 2. That will get me the 4 marks because I've shown all of my workings. Question 22. Work out 1 3/4 times 1 1/3. Give your answer as a mixed number. It's really important when you're working with fractions, if you're multiplying them, that you ensure every part has been multiplied. I would suggest that the best way to do this is to convert these mixed numbers, whole numbers and fractions, into improper fractions before you start. So 1 3/4, I know a whole one must be 4/4, plus the 3/4 I've got here gives me 7/4. And 1 1/3 is the same as, well, I know that a whole one must be 3/3 plus the 1/3 I've got here, so that's 4/3. So I've converted those to improper fractions first of all. I'm then going to multiply them, so 7/4 times 4/3. Okay, so if we want to do this a longhand, we would do 7 times 4, that's 28, divided by 4 times 3, which is 12. We could make this a bit quicker, and I'm just going to show you a quicker way to do it up here. So 7/4 times 4/3. I know that if I multiply, the numbers, doesn't matter which order I do them in, so we could change the top to be 4 times 7, so we get 4/4 and 7/3. 4/4 is 1. So this is the same as 1 times 7/3, which is 7/3. Now, if I simplify the version I had over here on the left, I could divide them both by 2, for example, to start off with. I get 14/6. And if I divide by 2 again, I get 7/3. It says leave your answer as a mixed number. If I leave this as it is, 7/3, I won't get that final answer mark, so I would only get 2 out of 3 marks. I need to change it back from an improper fraction to a mixed number. So 7/3, how many 3's are in 7? There's 2 whole ones with 1 left over. So the answer is 2 1/3. Use a ruler and compasses to construct the line from the point P perpendicular to the line CD. You must show all construction lines. So for this one, you will need a set of compasses, and you're looking to draw a line that is perpendicular, meaning at right angles, to the line CD through the point P. But we need to construct it, so we need to make sure we're using the compasses to do that. So I couldn't video myself doing the construction, so I've done Blue Peter style. Here's one I prepared earlier. And I'm going to just talk you through how I did it. So first of all, I opened up my compasses until they were wide enough to put the tip on point P, and then it would draw an arc over the line and intersect the line CD. So I drew this arc that intersected the line CD, first of all, this one. And then once I'd done that, I kept my compasses the same width, and I put the tip of the compass on the intersection between the arc and the line CD, and then I drew another arc, which gave me this one. And then once I'd drawn that arc, I put the tip on the other intersection of the arc and the line CD and drew this arc. And then once I'd drawn those two, I got my ruler and I drew a line through where the arcs intersected down here and the point P, and joined up to make the perpendicular line. That line then is at right angles to the line CD, creating the perpendicular. 24. The diagram shows triangle ABC. ADB is a straight line. The size of angle DCB to the size of angle ACD is equal to 2 to 1. Work out the size of angle BDC. So let's just unpick what some of these letters mean then. So first of all, we've got triangle ABC. Well, A, B and C, that's just representing this triangle. ADB is a straight line, so A down to D down to B is a straight line. The size of angle DCB, so let's unpick that. D, let's start at D and go to C and then go back to B, so that's that one, is in the ratio 2 to 1 with the size of angle ACD. So A, let's start at A and go to C and then go back to D. So we get this angle here. So what that's telling us is that this green angle is twice the size of this red angle. So if I label this red angle X, then the green angle must be 2x, twice as big. It then asks me to work out the size of angle BDC. So let's just have a look at what angle that is. BDC, so if we start at B, go to D, and then back to C, that creates this blue angle here. Okay, so that's ultimately what I'm trying to work out, that blue angle. At the moment, I know that this angle is 51 down the bottom, and I know that the top angle is 75. And I know that angles in a triangle add up to 180. So if I work out what this missing angle is over here, the 2x add the x, the angle BCA, I can then work out what the value of x is. So let's start off by doing that. So let's do 180, take away 75, take away 51. And if we work that out, that leaves us with 54 degrees. So I know that angle BCA is equal to 54 degrees, all of it. What I really want to know, though, is what the size of angle BCD is, because that's in the triangle that ultimately I need to work out the blue angle BDC. So let's start with this BCA. BCA is 54 degrees. That's this one here, all of this one. And I know that that is 2x add x. So 2x add x is 3 x's, and that's equal to 54 degrees. So if I want to find 1x, I'm going to divide both sides by 3. So it leaves me with x on this side, and on this side it leaves me with 18 degrees. Could have done a little bus stop method for that. So 18 degrees is x, but I want to know what 2x is. So 2x is 2 times 18, so 2x is 36 degrees. So I now know that this angle is 36 degrees. Okay, I still know there's 180 degrees in a triangle, and I want to work out this blue angle here, up here. So I now know that I've got 51 down in this bottom corner at B. I've got 36 degrees as angle BCD. And if I do 180, take away 51, take away the 36, That leaves me with 93 degrees. And that 93 degrees is this angle here. So my answer, the size of angle BDC, is equal to 93 degrees. Question 25. 4 red bricks have a mean weight of 5 kilograms, 5 blue bricks have a mean weight of 9 kilograms, and 1 green brick has a weight of 6 kilograms. Donna says the mean weight of the 10 bricks is less than 7 kilograms. Is Donna correct? You must show how you get your answer. Okay, so this is for 3 marks. We need to show all our workings. We know that the 4 red bricks have a mean weight of 5 kilograms. 5 blue bricks have a mean weight of 9 kilograms. And 1 green brick has a weight of 6 kilograms. Okay, so let's start with the red bricks. 4 red bricks have a mean weight of 5 kilograms. So that means that using the mean, on average, each brick weighs 5 kilograms. So in total, I know that because each one on average weighs 5 kilograms, all of them added together is 4 lots of 5, which is 20 kilograms. So for the red bricks, that's 20 kilograms. Let's go to the blue then. So it says that they have a mean weight of 9 kilograms. So 5 blue bricks each have a mean weight of 9 kilograms. So if I do 5 times 9, that gives me 45 kilograms. And finally, the green brick, there's only one of them, and they tell me that that weighs 6 kilograms. So that's 6 kilograms there. So I've got 10 bricks, and I can work out their total weight now. So if I add all that up, I think I get 71 kilograms. So I've got 10 bricks, so 71 kilograms for the total of them. Now, if I find the mean weight for those 10 bricks, I would do 71 divided by 10, and that would give me 7.1 kilograms as the mean weight for all of them. Doesn't matter what their colour is, so she is incorrect. Or Donna is wrong. It is 0.1 kilograms more. Question 26a. Simplify p squared to the power of 5. This means we're multiplying p squared by itself 5 times. So when we're multiplying with the same base, we can add the powers. So I've got 5 lots of 2, which is p to the power of 10. So if we were thinking about it just as the brackets, we can think of this as p to the power of 2 times 5, which is p to the power of 10. We're going to simplify on part B, 12x to the 7 y cubed divided by 6x cubed y. I'm going to rewrite this as a fraction. I've got 12x to the 7 y cubed divided by 6x cubed y. I'm going to take each part in turn. So I'm going to start with the coefficient. 12 divided by 6. If I divide top and bottom by 6, I end up with 2 here and a 1 here. Here, x to the 7 divided by x cubed, or if I'm dividing with the same base, I subtract the powers. So I end up with x to the 4 and a 1 on the bottom. So that becomes a 4. And I've got y cubed divided by y. That's y to the power of 1. So I subtract the powers again. So I'm going to end up with y to the power of 2. So I end up with 2x to the 4 y squared divided by 1, which leaves me just with 2x to the 4 y squared. Question 27. The accurate scale drawing shows the positions of port P and a lighthouse L. The scale, 1 centimetre, represents 4 kilometres. Alina sails her boat from port P on a bearing of 70 degrees. She sails for 1.5 hours at an average speed of 12 kilometres per hour to a port Q. Find, firstly, the distance in kilometres of port Q from lighthouse L, and then the bearing of port Q from lighthouse L. So to do this, we need to look at some key pieces of information. So we need to think about this scale. 1 centimetre represents 4 kilometres. We're going to have to put where port Q is on this diagram. We've got this bearing of 70 degrees. So that's the line and the angle that we need to go out from port P on. We know that she sails for 1.5 hours at a speed of 12 kilometres per hour to port Q. So if we know all that information, we can then put that onto our diagram and find where port Q is. So as before, here's one I prepared earlier, Blue Peter style. I'm looking to find where the 70 degrees is. So I have used my protractor and used this north line coming out of P and measured round an angle of 70 degrees clockwise. I've then put a little dot here at the edge of my protractor, you can see. I've then used my ruler to draw a line of 4.5 centimetres and put port Q at the end of that line. The reason I've drawn the line 4.5 centimetres is because it tells me that she sailed for 1.5 hours at a speed of 12 kilometres per hour to port Q. From that, I can work out how far she travelled. I know that in 1 hour, she would travel 12 kilometres. That means that in 1.5 hours, which is 1.5 times bigger, she would travel 12 times 1.5 kilometres, which gives me 18 kilometres. 18 kilometres then, I need to do 18 divided by 4, which gives me 4.5 centimetres using the scale that they told us here. 1 centimetre represents 4 kilometres. Now I've had to draw in that point Q because for part 2 it says what's the bearing of port Q from lighthouse L. Now I've got Q on my diagram now. I've got L with its north line in, and to find the bearing I go clockwise from the north line round to this line that joins Q to L. So when I join that round, I can measure that with my protractor, and that's 320 degrees. It will give you a little bit of room for error on the mark scheme, so I think if it's between 317 and 325 degrees, you're absolutely fine. So finally, to answer this then, the distance Q to L we need to find out is measuring this length here, 5 centimetres, when I look on the when I measure it on my diagram. So if I work out the distance, I've got 4 times 5, so 4 kilometres for every centimetre on the map. That gives me 20 kilometres, so that distance is 20 kilometres, and the bearing of Q from L is 320 degrees. Question 28. The diagram shows triangle AOB. Angle AOB is not an obtuse angle. Find the greatest value of x. You must show all your working. So we know that angle AOB, this one down the bottom here, is not an obtuse angle. It must be an acute angle or a right angle then. So if we want the greatest value of x, as it says here, then we're going to assume that it is 90 degrees, a right angle. So when I sum the 2x, the 3x and the 10, I get 90 degrees. That will produce the greatest value of x. So I'm going to write that down to show the examiner. 2x plus 3x plus 10, that must equal 90 degrees to get the greatest value of x. I then can collect the 2x and the 3x together. It gives me 5x plus the 10 equals 90. Now I've got a little linear equation to solve. So I'm going to subtract 10 from both sides. That gives me 5x equals 80. And then I've got 5 lots of x. So to have 1 lot of x, I'm going to divide by 5 on both sides. And so x is equal to 16. 16 is the value of x when we assume that the angle is 90 degrees to make x the greatest value as it asks. Question 29. ABC and PQR are similar right-angled triangles. Angle ABC equals angle PQR. Work out the length of PR. So we've got similar right-angled triangles here, which means that one is an enlargement of the other. So angle ABC, this angle here, is the same as this angle here, PQR. So I've got some corresponding sides here. So RQ and BC are corresponding. I need to find out what my multiplier is to get from 15 to 10, because I need to work out the length PR. So I need to go from 9 down to something, and then once I've worked out my multiplier, I can use the same multiplier on the 9, and that will give me the length PR. So how do I get from 15 to 10? Well, I know that multiplier has to be less than 1 because I've got a number, I've gone from a bigger number to a smaller number. So I'm going to multiply by 10 over 15. Now 10 over 15 in its simplest form, if I divide top and bottom by 5, is 2/3. So my multiplier is 2/3. That makes it easier with this number 9 up here. So if I multiply 9 by 2/3, well, 1/3 would be 3, so 2/3 would be 6. So I get 6 centimetres for the length of PR. Triangle EGH is congruent to triangle KGF. HK is 10 centimetres, HG is 4 centimetres. Work out the length EF. So the length EF is up here. They've told me that HK is 10 centimetres, so I know that this length here is 10 centimetres, and I also know that HG is 4 centimetres, just on that bit there. Now, I want the length EF, but because these are congruent triangles, congruent meaning exactly the same size and shape, this base HG is the same as this length GF. So I know that GF is also equal to 4 centimetres. They've told me HK is 10 centimetres. That must mean that GK is 6 centimetres in there. So if GK is 6 centimetres, that must also mean that GE is 6 centimetres. And I'm looking to find EF. So if I do GE and I take away GF, that will leave me with EF. GE was 6 centimetres, GF was 4 centimetres, and that will leave me with EF, which is 2 centimetres. So the answer is 2 centimetres.